All right, in the past, on lesson 4-1, we looked at different measures of acute angles. We looked for finding side lengths and angles using the psi y, cos x, tangent is y over x. Today, we're going to look at how do we go from degree to radians, which you heard me speak about last lesson in 4-1, and how we can use these to solve real-world problems. So let's take a look. We got some new vocabulary in here. The initial side is just the beginning. So when you see this, this is where you begin. The terminal side is where the angle ends. So terminal means ending, initial means beginning. Standard position, that's what I was referring to last lesson when I said the angle has to be on the x-axis. Okay, that'll be the standard position where theta is on the x-axis. And radians is just kind of like a degree. It's another method of measurement. Coterminal means they share the same ending point. And this is referring to angles. And linear speed, angular speed, it's just different measures of how we can calculate. You know linear speed, it's like a car. When it's going 70 miles an hour, it's moving linearly. Angular is things that are moving in a circle. How fast would like the tires be spinning? That would be angular speed. And a sector would just be a portion of a circle. All right, so there's your vocabulary. Let's get started. The first part, it says write 329.125 degrees in DMS form. This means not only degrees, but degree, minutes, and seconds form. Okay, so they can break down degrees just like we do with a clock. Instead of having hours, minutes, and seconds, we have degrees, minutes, and seconds. Now, in a circle, you can have up to 360 degrees. You can have up to 60 minutes in 1 degree, and minutes has one little dash here. And you can have 60 seconds in 1 minute. Okay, so 60 seconds to 1 minute, 60 minutes in 1 degree, and 360 degrees in a circle. And so these will all play out. Now here's how we calculate this. So given here, we have 329 full degrees, but we have also, this is the same thing as saying 329 degrees plus 0.125 degrees. Now if we take this, we can change it into minutes and seconds. The way to do so is this is the same thing as 0.125 times 60 minutes because if you think about it, there are, let me do it this way, 60, I'll use a little IPC or science for you. There's 60 minutes in 1 degree. And so if I multiply these out, the degree symbols would cancel each other out. Those would go away, and I could find out how many minutes this is. So I go to my calculator, and I'm going to type in 0.125 times 60, and we get 7.5. So this equals here 7.5 minutes. Well, if I wanted to get rid of the minutes, I would then come back over here, and I would take, this is the same thing as saying 7 minutes plus 0.5 minutes. If I take that 0.5, I could say, well, that's the same thing as 0.5 minutes times 60 seconds per 1 minute. And now these little tick marks cancel out here, and so we would find out that that is equal to 30 seconds. So all in all, we have 329 degrees, 7 minutes, and 30 seconds. And that would be my answer. And let's try another one here. So this time they give it to me in DMS form. And it says write it in decimal degree form. That just means we have a decimal with a degree. So I have 35 degrees plus 12 minutes plus 7 seconds. So we would do the opposite. Whereas this problem we multiplied by the 60s, this time we will divide. So we have 35 full degrees plus 12 minutes. So if I wanted to get rid of minutes, what I would do is I would divide by minutes, which means I would have 1 degree per 1 degree per 60 minutes. And so that'll cancel that one out. And then I'll also have over here 7 seconds, which to get rid of that, you would divide by seconds. Well, there's 60 seconds in 1 minute. And to get it back to degrees, I would divide this again. There are 60 minutes in 1 degree. And so here, when I look at these symbols, these would cancel now. And so I would have 35 degrees plus, it would be 12 degrees over 60. And then here, plus, this would be 7, and the minutes, or the seconds cancel out, the minutes cancel out. So it would be 7 over 60 times 60. And this would then be in degrees. And so we just combine these. Let's see here. So if I go to my calculator, I would have 35 plus, the first fraction was 12 over 60. 12 over 60. And then we would add that to 7 over 60 times 60. 7 over 60 times 60, which is the same thing as 3,600. I press enter and it gives me this fraction. If I press enter again, it'll give it to me in decimal form. So the answer would be 32.2019444. That means when I round, this is about 35.2. We'll round it to 2019. That's what I'll round it to. 2019 degrees. Oh, it says to the nearest thousandth. I'm sorry. So we would round this up to a 2 there. Thousandth has 3 zeros, so I need to have 3 decimal places. And this would be my answer. So now I have one here for you to try. Let's see if you can convert this from decimal degree to DMS form.